Hello everyone and welcome back. So in our previous video, we started a new chapter in our machine learning journey, and that was regression algorithms. So we use linear regression to predict the profits of our ice cream based on the temperature of the day. In today's video, we'll be implementing one of my favorite algorithms, which is random forest algorithm. We will use it to predict the life expectancy. And by the end of this video, I will share some of the reasons why random forest is my favorite algorithm. So for this and more, let's dive into it. Alright, so the dataset we'll be using is life expectancy dataset, okay? So you can get it from Kaggle. I will also leave the link down below. You can just click on the link and then it will navigate you to this page. Once you come here, you can just click on download and download it. The dataset, you have to pre-process it, okay? And we've covered that already. So I have a video on data preprocessing for which we used the life expectancy dataset. So you can just watch that video if you haven't and then pre-process your data. Once you are done, just call or save your data set in a variable. Once you are done with the encoding, just save it in a variable and then call the dataset dot to CSV and then give a name to it, okay, so that you can save the pre-processed data. Once you save it, let me show you how it will be. Okay, so once you save it, just copy it, okay, copy it from the working directory and place it in the new working directory you are working in. Okay, so I have mine here already, so you have to copy it and paste it in the new working directory. And once you are done with this, you can start with the implementation. So I'm just going to go back. Okay, so before we start with the implementation, let me give you some overview of how random forest works. Okay, so in simple terms, random forest is basically a multiple decision trees. Okay, so one might ask, what is decision tree? Let me just take you through. I have a note I got from one of my lecturers. Okay, so I would like to share that one with you. So the idea and behind decision trees is also a form of algorithm. Okay, it just takes the training data set, okay, and use that to develop a tree. All right, and use the testing data to predict. Okay, so let me quickly just take you through so that you just get a basic idea about what decision tree is. Once you know that, you just know that multiple decision tree is a random forest. Okay, so here we are trying to predict whether it's blue or green, right? So here when you look at it, we have our X and Y, right? So yeah, our Y and X axis. Okay, so when you look at it, when you start, it asks whether X2 is greater than 5. So you come to X2, which is our X axis. So if it's greater than 5, which is from here to here, right? If it's greater than 5, what X? So if it's greater than 5 years, you come here and it checks if X1 is greater than 8. So once you get here, X1, you go upwards. Okay, so if X1 is greater than 8, so it means it will be this session. Okay, yeah, if that is the case, then it's green. Okay, right. If no, it's blue, right? So if it's not greater than 8, then it's less than 8. In that case, it will be the session. Okay, now when you come here to if it's less than 5, here you are saying if it's greater than 5, yes, but what if it's less than 5? If it's less than 5, then you are going to consider this session. Now you ask yourself, is it greater than 2? If it's greater than 2, then it's this session, right? It's this session. So in that case, it's blue, right? If not, then it's green. So you see, basically, we are using the data set, which is the training data set, to develop some kind of tree. Okay, and you use your testing data set to make predictions. Okay, yeah, so that is the idea behind decision tree. And when you have a couple of decision trees, that is random forest. Okay, so now let me give you some of the reasons why it's one of my favorite. In fact, I use this one in my final year project. Okay, and one of the reasons is there is no overfitting. Okay, so when you use multiple trees, you reduce the risk overfitting, and it has less training time. Okay, so the time it takes to train the model is very less, and it also has high accuracy, which means it runs efficiently on large data sets as well. Okay, and the last but not the least is it estimates missing data. So when you're working with a data or a data set that has a lot of missing data, I would recommend random forest for you because it has the ability to make or estimate missing data, okay, and maintain accuracy as well. Okay, yeah, so that is some of the reasons. So let me quickly go back again. No overfitting, it has a less training time, it has high accuracy, and it performs well in a data set with high missing values. Okay, so with that being said, let's start with the implementation. So the first thing we are going to do as usual is to import our libraries. Okay, so I'm just going to paste them here, and like how we've been doing it always, the only thing that changes is the random forest. Okay, so I'm just going to run that, and we come here and create a data. Okay, and then we are going to call pd, which is pandas read csv. Okay, csv, and here we are supposed to pass in the name of our data set. So I'm just going to go back and copy everything together with the extension. So I'm just going to copy everything and paste it right here. Okay, why is it taking too long to import? Okay, yeah, so once it's done, we have to now run the second step, okay, which is loading the data set. So once we load the data set, we can take a look at how the data looks. So I'm just going to paste or just type data. Okay, so we have 2,938 rows with 21 columns. Okay, so this is the pre-processed data. Okay, and looking at it right here, I think you have fair idea about the data set. Okay, you can also just come here and let's open it here too and see how it looks. Okay, so we have the year, we have life expectancy, adult mortality, we have infant deaths, alcohol percentage or expenditure. So we have a lot of columns here, and based on that, I think we have only status as our categorical. Okay, yeah, but I think we've already dealt with that. So let's just go back and continue with what you are doing. Okay, so you can also type info and get more information about our data. Oops, info. Okay, so you can get more information about data. The next thing is to first let's split our data set into labels and features. Okay, and looking at our data set straight away, I don't really have fair idea about how the data is, but I know straight away year won't be needed. Okay, yeah, and life expectancy is going to be our label, so the rest will be our features. Okay, you can just come here, and then we are going to call our x, which is our features. So our data dot drop, so we are going to drop year and then life expectancy, so the rest will be our features. Okay, so I'm just going to get a list, and I'm going to call year and life expectancy. So let me just copy life expectancy. Okay, yeah, oops, it has to be in okay. And one thing I realized or I noticed earlier on was that with our life expectancy, we see when we look at it, we have some space here. Okay, so if you don't bring the space, you're going to encounter error. So I'm just going to bring a space after the y. Okay, yeah, and then we're just going to say as this equals 1. Okay, and our y will be our life expectancy, so data life expectancy. So I'm just going to copy this and paste it right here. Okay, so that's our life expectancy. So I'm just going to run that, and now we can take a look at it. So basically divided it or split it into our features and labels. So these are our features and our label is this one. Okay, so we are going to use our features to predict our labels, right? Okay, so now let's split now the two data sets into training and testing. Okay, and I'm just quickly going to do that. So training x test y underscore train, and then y underscore test. Okay, so I'm just going to call our train test split function. Okay, so I'm just going to call here, pass my x and y, and I'm just going to state my test size, which is going to be 0.2, which is 20%, and then my random state, okay, is 42. Okay, so as I explained in those previous videos, what you are basically doing here is we are basically stating that, for instance, our features, we want to split it into training and testing. Okay, and with our training we want 80% of the x, and our testing we want 20% of that. Okay, and yeah, so that is basically what we are doing here. So I'm just going to run that, and the next thing we are going to do is actually initialize our model and train it. Okay, so just going to create random forest model, okay, a variable, and I'm going to call my random forest classifier or regressor. Yeah, this is a regression problem, so not classifier. Yeah. So I'm just going to paste it, and we have a couple of parameters. So we have number of estimators, okay, and I'll set it to 100 for now, and then my random state, I'll set it to okay, let's continue with the 42. Okay, so there are a couple of parameters as well. You can just fine tune or change the parameters. You can just Google and get the other parameters and change them, okay, just to make your model perform better. All right, but for now let's just use the n estimators and our random state. Oh, not okay, random state. Okay, yeah. So now let's try and train our model. So rf underscore model dot fit. Okay, so we are going to pass our x train and our y train. So x train, and then just going to copy my y train here. Okay, so let's run it. Oops, what's wrong? Estimators. My bad, typo. Okay, great. So let's wait for it. All right, so we've been able to train our model. So the next thing is to make predictions. Okay, so that's the reason why we are training the model, obviously. So let's come down here and call our model. Okay, so I'm just going to call our model here and call predict on it. Okay, and what I'm going to do is pass in our x test. So this is our features here. Okay, and I'm going to run it. So you see, let me save it in a variable. Okay, so I'm just going to call it y underscore pred, just for predict. Okay, and let me run it. So we are going to use the predicted values to evaluate it. Okay, and we are going to evaluate it based on mean square error and out2 score. Okay, so the predicted values are the life expectancies. Okay, so I'm just going to come down here for evaluation session. Let me just I'll delete them, but I just want to so with our root mean square error, we are going to call this function. Okay, and we are going to pass in the y test and then the predicted value. So it will compare them, and based on that, it will give us. So let me just come down here. So we have our Y test. Okay. So let me just bring it here, and then I'll call my Y predict as well. Great. And then I'll do same for R square, R2. Okay. So that one, so I'll just call my R2 score function right here, and I'm going to pass in these two. Copy that. And I'm going to paste them here. So now I can delete these ones. Okay. So permit me, if you are getting some noise feedback, I'll try and suppress some of them. Okay. Yeah, I've changed my location, so that's why. So let's just say mean squared. Oops, what's wrong here? Mean squared error. Okay. And it's supposed to be in. Great. And I'm just going to pass my mean square error here. And I'm going to print another one for our R squared. Oops, what's wrong? Hey, okay. So our R squared score. Okay. And that one too, we are going to pass out to here. Okay, so now we can evaluate it. All right. Yeah, so now as you can see, our model had 96%. Okay, so 96.8%, and our root mean square error is 2.7. The best we can get is 0. So whilst it's approaching 0, you should know your model is performing. Okay, so I'll create a new cell, and I'm going to just copy and paste an algorithm. I just got it down so that we can actually get some stuff done. Okay, so here what I'm trying to do is I'm trying to print out the input, okay, and then the predicted output, and then the actual output of the model. Okay, so this model, we fed it with some where is it, girl? Yeah, we fed it with text, right? So I'm just going to, for each role, I'm going to print the input, and then print the predicted value for that one, and then the actual one, so that we can just do some comparison there. Okay, so I'm just going to run that one too. Okay, great. So as you can see here, these are input fields, right? And we have the predicted output was 72.9, right? But the actual was 73.7. So which is kind of really close, right? For instance, the second one too, we had 76.0, okay, 9. And the actual is 75.9. So it's really close, right? Yeah, so that is it for that. So we've been able to design our model to predict the life expectancy for that. Okay, and this is a regression problem. That's why we are getting values. If it's a classification, there will be some categories that it will classify them under, but this is a regression problem. So our output is going to be a variable based output, right? Now the last thing we'll do is to save the model. Okay, so we are going to use the dump method or function. Okay, so I'm just going to paste it right here. So what you are going to do is get the model. So our model was RM. Okay, so we are just going to get our model here, and then we are going to give it a name. So I prefer this name. Okay, so before that, you see, we only have this 3, and now let's save our model and see. Okay, so now let's go back. So we've been able to save our model, right? Yeah, so that is it for this video. We've been able to implement random forest algorithm, right? And I hope you really enjoyed this video. If you did, kindly click on the subscribe button, share this video with friends, leave your comment in the comment section. And my India guys, okay, I really appreciate you guys, and I'm determined to even learn your language. So if you are Indian and you are watching this video, kindly give me a thumb in the comment section if you'll be willing to teach me your language. Okay, I really want to learn your language. And thank you guys for watching this video. See you in the next video.